360 by n for the two-stroke engine, and also have theta equal to 720 by n for the four-stroke engine. Now it's no longer valid. This one is cannot be used. Okay, cannot be used. The reason is why there is no, there is the position of the crank is not divided by the stroke. The position of the engagement of the configuration of the engine is given by the what? Acute angle. Acute angle. Acute angle. Acute angle. Equi means same. So now, how is it? For example, you have radial. For radial, 8 cylinder. So your theta is equal to 360 by 8. By default, a four-stroke engine. So this will be your theta. Okay. For V, of course, you cannot use this one. For V, cannot use this one. For V, what? For V, look at for V engine. Remember, for V engine, this theta is given by what? Given by the notch, N-O-T-C-H. Notch between cylinder. What is notch? Okay, the notch will be this one. This is the notch. The notch given by the notch between cylinder divided by 2. So how is it? When you're saying that divided by 2, so you divide this one by 2. So supposing example 60, notch is equal to 60. So theta equal to 60 divided by 2. So you'll have 30 degrees measured from the where? The crank to the line of stroke. So this one will be 30. The next one will be 30. Okay, and the notch, this one must be measured from line of stroke to another line. So it's not from the crank to crank. No, sorry, it's not from the connecting rod to the connecting rod. This is measured from line of stroke to line. So notch, yes, measured from line of stroke to line of stroke. To line of stroke, line of stroke to line of stroke. This is the notes. So now let's start now solve the problem. How about the equation? How about the equation? Equation involved. How about equation? Equation exactly at the same what we did earlier. What is that? It's F. Now this is mr omega square cos theta plus the m omega square r cos 2 theta divided by n. But remember, you have this one is secondary. Sorry, this one primary. This one is secondary. This one you have primary direct. This one we have primary reverse. Same thing as this one. We have secondary direct, secondary reverse. So the equation as I give you in class, so the F primary direct is equal to N. This one is M omega square cos theta divided by 2. Correct? For the secondary direct, for example, secondary direct, you will have this one F, second direct. So you have N, correct? This one is M omega square R cos 2 theta divided by 2N. Okay, this N is number of cylinder. The small n is the ratio. Okay lah, okay? Okay, now let's start solve the problem now. Yes, any question? No? Okay, you have question, just speak up, yeah. So you have the results here. Come back to this one. So this is the thing that we're going to construct this one, and you found that the crank will be placed at cylinder number 1. This is the common crank placed cylinder number 1. So this one become what? Become reference. Okay, supposingly the crank is located here in between, for example, between 1 and 3. Doesn't matter now, yeah. You just push the crank to be located vertically. Okay, now if you go, you found in books, so many books, you found that the crank is not exactly at the vertical. It's between the vertical. It's in the 1 and 2, 1 and 4, and so forth. Whatever you have, push the crank to be vertical upward. It can also be vertical downward. Now I'm going to put the crank vertically. So this is my my results. Crank will be here, and 1, 2, 3, and 4 as given. And they also provide me as this one. What they provide the direction. This one very important, the direction. So we follow the direction clockwise from your seat. This one, and what else? And the crank is located as crank number 1 is correct also. This is the given. This one is given. It's not given how? This one not given. It's not given. You have to make what? Assumption. It's not given. If given, follow the instruction. Okay. Do we need the firing order? No, no. Do you need a firing order? No, we don't need the firing order. Okay, now we are going to construct now. What are you going to construct now? Constructing the primary direct crank. Then we have primary reverse crank. Then we have secondary direct crank, secondary reverse crank. Okay, this one 4 polygon. A polygon of crank diagram. Okay, now start. Primary direct crank. Okay, theta. What is theta? Theta is equal to 360 divided by 4 will give you 90. So everyone is 90 degrees as given. Correct? So now, so this is your result. So your theta now is equal to 90 degrees. So how to construct? It's not very difficult. Here, jump. Okay, so you have. Okay, now remember now. This is for test. This is for test. Only for test. Or exam, for example. So I already mentioned. I already make my conclusion. If you remember, for primary direct is always what? Remember, what do I say in my class? For primary direct is always not. Is always not.
Always unbalanced.
Balanced, unbalanced. So you don't have to do anything. Just put it 1, 2, 3, and 4. That's it. If it's 12 cylinder, put it 12. So it's so definite that the primary direct is always not balanced. So the result will be the F primary direct is equal to, and this one be your M omega square up. This one is cos theta divided by N. Divided by N. Divided by what? Divided by 2. So this cos theta, how are you going to get rid of the cos theta now? How are you get rid of cos theta? Cos theta is equal to cos 0 equal to 1. Why 0? Because I already assumed that my angle here stand as 0 here. Okay, this is 0 degrees. Okay, any question? No. Okay, fine. The next one is a primary reverse crank, where you found that your theta now is equal to negative 90. This negative is just to say to us, or perhaps to indicate to us, it is basically representing the reverse. How is it? Now we come back to here. This is the results. This one is the results here, and this one omega. Yeah, this one is omega. We have another one reverse omega. 1 will be here. Why 1 will be reference? Why 1 is reference? Why? Why I put 1 as reference, class? Why? Anyone know? Why? Because what? Because what? Because the crank. Look at the common crank where the place. Because they place the common crank as lane number 1. This one. So 1 will be your reference. Okay, so we go back to here. We go back to here. So 1 will be reference. So the next one I'm going to put 2 now. So this is my working. I'm going to put under the color so they can easy to differentiate. So this is my working, yeah. Of course, you don't need this working in your calculation, yeah. So this one is given. This is given 1, 2, 3, and 4 given. So my result will be. Okay. For cylinder number 2 here, isn't it? So this one is measured on the line also 2 common crank. You move 3 segment, correct? Isn't it? 3 segment. Yes, 3 segment. But when you are talking about the reverse, you also need to move 3 segment, but opposite direction. Move 3 segment here, so you will fall this one, cylinder number 2. Yes or no? Number 3. Number 3, you move 2 segment. Am I correct? Following this one, move 2 segment following the given direction. Now you have to move 2 segment, but opposite direction. It's number 3. Number 4, look at number 4. You move 1 segment. Number 4 is here. Number 4 here. This one our reference. Move 1 segment following the given direction. But now you have to move 1 segment reverse. 4 will be here. Balance or not balance? Balance. So your F primary reverse equal to 0. So what will be the result? The result will be the F primary is equal to what you be getting here. Your N will be 4. This one divided by 2. This one is M omega square plus 0. So that will be the result. 2M omega square Newton. Of course, Newton. Omega square up here. Newton. That will be the result. And this is pointing upwards. And do the next one. And do the next one. How is it? Is the secondary now. Secondary. Okay, secondary. Focus on secondary. So you have secondary direct crank where your theta equal to 2 theta, yeah, become 180. Because theta is equal to 90 just now, 2 theta become 180. So how is it? This one will be your results. Now is 2 omega, 1 will be here. So this is your working. 1, 2, 3, 4. Cylinder number 2. This one is the given one. Move 3 segment. 3 segments, it becomes 6 segment. How is it? 1, 2, 3, 4, 5, 6. 2 will here. Correct? The next one, cylinder number 2. How many segments? Cylinder number 3. How many segments? Move 2 segments. 1, 2. It become 4. 1, 2, 3, 4. Cylinder number 3. Number 4, only 1 segment. So you move 2 segments. 4 here. Balance not is balance. So your F secondary direct is equal to 0. Easy one. It's the test question. Now move to the next one. Now it's as a reverse crank where your 2 theta is negative 180. Again, this is your results. 1 is here. The other one is 2 omega. 2 omega. So this is your working. 1, 2, 3, and 4. This one is given omega. Cylinder number 2, move how many segments? 3 segments. It becomes 6 segments. But now it also moves 6 segments, but opposite direction. How is it? It'll be moving or rotating this one, 6 segments. Holding this one. Okay, 6 segments. How is it? This one is 1, 2, 3, 4, 5, 6. 2 here. Correct or not? Correct or not? Number 3, 2 segments now become 4 segments, but opposite direction. Okay, 1, 2, 3, 4, 3. Obviously, number 4 be here. Prove it. 1 segment. Okay, now become 2 segments because you are talking about secondary reverse 2 segment, and it is balanced. So F secondary direct reverse is also 0. So finally, if you look at very careful, you found that the F secondary is equal to F secondary direct plus F secondary reverse equal to 0. So therefore, your total F is equal to F primary plus F secondary. And that will be the result is of course in vector. So if the question asks perhaps, okay, you know the result earlier. This one is 2 m omega square adjacent plus 0, right? Okay, now, and you know that it's pointing upward. If the result is the question keep asking you, state or explain how to balance. Okay, it's easy. So this is your engine just now. This is your engine. Okay, let me put the actual one. This is your engine, yeah? This one, I'm going to construct this one. Yeah? This is the given engine. And rather than that, The unbalanced force is basically the m omega square r. This one is 2 Newton and pointing upward, isn't it? It's pointing upward. It's basically pointing this one. This is here. So you want to balance the engine, you have to put something on the crank. This one on the crank. So this one is negative 2m omega square r Newton, pointing downward. Then the system is balanced. That is how to balance the engines. Any question? Any question? No. Okay.
I have some question.
Yes, please.
If supposedly the question, the common crank, the question give us the common crank is not fall at 0 degree. Can we move the common crank to the 0 degree?
Okay. I will ask that one. I will answer your question. Supposingly you found that I can understand your question. Yeah. Supposingly you found that the crank will be located as here, for example. Yeah. This one a big circle. This one all your cylinder here, and this is your cylinder. This one is your here, and you found that the crank will be here. Is that your question?
Yes, Doctor.
Okay, is that your question? You have two possibility. One, you need to push this crank, push this one, push it to vertical. Vertical where? It can be vertical, upward, or downward. Doesn't matter. Or yeah, or downward. In conclusion, you have to what? Make sure this one be vertical. Doesn't matter downward or upward. Okay? Must be vertical. Any question? Am I answering your question? No?
Can we use horizontal? If the question give us the reference of the degree 0 at the horizontal.
Yes, can. Let's say this one is 0 degree side. So it does. If you push this one, okay, yeah. If you use this one, it's still okay. But as you use this one, so you have to ensure that when you found out this one before here, so your crank, your opposite direction will be that one. It's very difficult for you, isn't it? It's very difficult for you to ensure that the easy part will be put it in vertically, even though it is not 0 here. Supposing this one 90 degrees, doesn't matter. This one is 180 to 70, doesn't matter, but in vertical. But typically, this one is not decided by the equation. You decide. You decide, except for the inline engine. For the radial engine, you decide where the 0 falls.
Okay, Doctor. Understand. Okay. Thank you.
Any question? Any other question? Otherwise, I move to the question number 3. Any question, class? No. Okay, now fine. Go to the next one. Okay, before I do this one, of course, I will explain a bit. Of course, yeah, because otherwise, you might be forget about equation or perhaps forget the thing that I'm going to do. So now let me explain a bit what is the fluctuation speed energy. So this one is extra note from what we learned earlier. This one is fluctuation, FULC, fluctuation of speed and energy. Okay, fluctuation of speed and energy. Okay, what you have here is basically, remember this one. The only equation you're going to use is beta E is equal to I alpha omega mean square. This is the only equation, and this equation is basically can be expanded by E max minus by E mean. Remember this one. This is the only equation. There's no other equation. If you're talking about vibration, so many equations we have to remember, isn't it? Okay, now this is the only equation. But you need to know what are the term. For example, I can be mean or half m r square if you're talking about solid one. Or it can also be I representing equal to m k square or m r square, where you found that k equal to r, for example. So depend on the equation. And what is the omega mean? Omega mean, yeah, mean. This one is basically the maximum omega plus the minimum omega you divided by 2. And that one is so obvious, the average one, isn't it? And the alpha, this one is basically, this is the alpha. What is the alpha? What did the alpha stand for? Is the fluctuation of speed. So the coefficient, there will no units. So you have this one omega max minus by the omega mean divided by the omega mean. Okay. In my note, perhaps I put here as omega 2 minus by omega 1 by the omega m. It is the same. So what else? Beta A. Beta is one. This is beta A. Beta, if beta stand alone, beta will be, is also coefficient. Is a coefficient of fluctuation of energy. E remain the energy, and this Emax and Emin is basically energy generated by the source, and also the other one is energy required by the receiver, for example. Okay, this is the only equation. Okay, now how I'm going to use this equation. This is very important. How do I get this one? Where can I get this one? I can only get Emax and Emin by doing this one. This one by doing what? Doing by energy analysis. So you cannot run away from energy analysis. How I'm going to do energy analysis? You must have what? What must you have? You must have T-mean, correct. Before T-mean, you must have turning moment diagram, isn't it? Then from this turning moment diagram, you have to have T-mean. Okay, what is T-mean? What is T-mean? T-mean is any torque which is constant. It can be from resistance. It can also be from source or from motor. Okay, now, or from input. Okay, now I'm going to solve. Okay, I'm going to solve the equation. Anything you like to add here? Oh, one thing. This one, this I. This I can also mean that I can also be mean I system. Remember? So what is I system? I system is typically the I rotating rotating parts of motor and machine. Remember in my class? And this one plus by I fly wheel. This one is typically given. This one is normally given. This one you need to find, because you need to find the parameter. This one you need to find. If this one is not given, so your I system is given by I. So you have to check the equation whether the check provide you I system or not. Okay, I'm going to solve this one. Any question before I move on to the solution to the question? Any question?
No, sir.
Okay, now move to this one. Okay, tell me, what is the function of flywheel? A short one, a brief one. What is the function? What is the function?
Store the energy.
Yeah, the storage of energy. Yeah, storage of energy. Full mark. You have a storage of energy, full mark. If you put another word, for example, what energy is as function is, the function of flywheel is to absorb energy when excess and to give away energy when required. Also good full marks. So when you start talking about storage, full marks. Typically 1 or 2 marks. Not carry so many marks. Yeah. Okay. So now number 2, B. What we have here is a shaft of an electric motor. So it is so definite they provide the motor. This one is now motor. Just put in mind. Okay, if this one is the graph coming from the equation, so the graph is coming from where? This one. They mentioned about this one is about the thing that they're talking about motor. So where will be this graph representing what? This graph representing machine. You have a machine, so rolling machine. So this one is representing by the machine. What about the motor graph? The motor graph is not defined because the motor will be definitely give you constant torque. Any constant torque will not be defined by the graph. The graph always give you the thing that fluctuate or varies. Remember that. Doesn't matter whether you're talking about internal combustion engine or you're talking about motor here. So as long as the graph given is basically coming from the one that keep fluctuating. In here, the machine will keep fluctuating because the machine required energy before the machine can do job or can do operation well. Okay, now they couple with a flywheel connected to common shaft. The torque required the rolling machine is shown here. This one is the torque required of the rolling machine. The motor drive the flywheel at a constant torque. They provide you another one, constant torque provide. Constant torque now is provide. So now it make you easier because they provide you constant torque. What else? The maximum minimum speed provide here. This one allow you to calculate. You have maximum minimum to calculate the omega mean and the average speeds. Determine the following. What are the following? Total number of product produced by the machine in 1 hour. In 1 hour here. Okay, 1 hour. So your solution or perhaps your equation is given as what is your equation? N is equal to 360 divided by T, isn't it? And remember this one belong for one cycle. And you need to recognize or you need to verify the given graph whether it's belong to one cycle or more than one cycle. But you need to know that whatever you've done here is a one cycle operation. Okay. So number one. Number two, magnitude of torque. Magnitude of torque, this one. What torque this one? Because they already provide the T-mean. Remember I did mention in my class? Yeah. What did I say about whatever you have a graph here, whatever graph you have, this one is T in Newton meter, this one is a theta in radian. Whatever graph you have here, you have to ensure that this Y and this X will be complete data, given data. This one is complete. This one also complete. So now T mean need to be calculated. You need to calculate T mean. Okay, when you found other graph, for example, also given by the T-meter moment diagram, this one, T in Newton meter, this one in radian, you have okay same graph, but suddenly you found that this one okay complete, and this one they provide you a method that uses T, for example, then they provide you all numbers. So this one is incomplete. Incomplete, yeah. So you found that this one T mean must be given. T mean must be given. Okay, go back to the equation. So that is what they provide you T mean. Because why? You have the incomplete what data in y-axis. It doesn't matter whether it's y-axis or x-axis. As long as there is incomplete data for the graph, the T mean will be provided. Otherwise, the equation is not correct. You T mean as the 70 Newton meter. So you don't have to calculate T mean now. Okay, the next one. Yes, any question? No. Okay, now mass moment of inertia of the flywheel I. This one is not very difficult, yeah. The next one now, when you calculated the I, then you need to use I to find what be the radius of the flywheel, and they also provide you this one, the ratio. The ratio of thickness to ratio of radius to thickness is 4. The ratio of radius to thickness is I to thickness equal to 4. Okay, now how to do this one, yeah. Okay, look at here. First, what I need now is to define the punching, number of punching. So let me use this one as my working space here, yeah. So they provide us N here is equal to 3,600 divided by T. So this T is belong to one cycle. Remember this one cycle. Then you need to check the given graph whether it belong to one cycle or more than cycle. Reading the graph is to verify the graph. So now let's start. This is 0, constant by 2 seconds, then it will gradually increase to 100, constant back, then it should shoot down here up to 9 seconds, then constant back. It start all over again, whether it start all over again at 16 or 14. Class. Anyone?
14.
Hello.
14.
So your T now is basically 14. So your N now is 3,600 divided by 14. As simple as ABC, isn't it? So if you calculate that one, you'll be getting, inshallah, remember this one, 257.14. That is the result of the actual answer for N when you divide it by 14. But remember, this is our product, yeah? When you do product, you mean that you must have the perfect product. So this one, yeah, this one is basically 257. Do not round up. It's only 257. So your equation, your answer must be 257. If you give 257.4, you deduct by half, for example. So check. Don't let the lecturer not deduct marks on the calculation here, because they want only 0.14. This one, you basically don't understand what the question asks you. Okay, number 2 is how to get T. How to get T. Okay, how to get T. Again, I'm going to use this one as my working. I'm going to clean up this one. I'm going to clean up everything. Okay, here, sorry guys. Okay, I'm going to clean up, and I'm going to say that I'm going to, to cut here up to 14, because I believe that it will be end at 14 for one cycle, and also been given here 70 will fall somewhere along 0 to 100. This one, let's say this one 70. This one what we call as T-min. Okay. So you need to know what T-min is. This one T-min given 70. So the graph will be two graph. One graph representing by the machine. This graph is representing by the machine. This one is by the machine. The other graph, the shaded by blue color, will be from the machine. The shaded area coming from the red one is from the motor. So you need to look the two graph here. So now using the conservation of energy, isn't it? And equation known as energy in is equal to energy out. So what I intend to share now is the in now will be coming from the top input equal to this one will be top output. Or in other words, I could also put here top from the motor because the motor will give you power to the machine, and this one is from the machine. Or in other words, by calculating the thing that we are shaded already, so this one is given by the motor will be the area shaded by the red ink, and the other one will be shaded by the blue ink. Isn't it? It's not very difficult, right? It's not very difficult. So let me do this one. I'm going now. Okay, put it here again. This is T theta by the motor is equal to T theta by the machine. You have here by the motor, of course, you have T min, this motor, right? T min 70 plus 40, by 14. So you have 70 multiplied by this one theta. But remember, theta must be in radian. Must be in radian. And you go back to the graph, you found that it's not in radian, this one in second. So how to convert this one? Conversion of theta by multiplying omega. So everyone will multiply by omega. So I go back here, I say to myself that, okay, 70 multiplied by omega. That will give you radian. Equal to, this one is the area given by the yellow area. This one is trapezium, this one is the rectangle. So you can work out on your own if half, this one is 2 omega, half 2 omega multiplied by 200. This one is 200, is it? 200. multiplied by this one, yeah, 200 multiplied by 9 by 4 is 5 omega. Okay, then you minus by the small portion, the under or below the this one below the origin, sorry, below the origin 0. This one is t multiplied by 14 by 9 is 5. 14 by 9 is 5. This one is t by 5 omega. Look at here. You have every term here and you have only one unknown parameter.
Their ability to hyper-focus
Yes.
and have different experiences is astounding.
Sorry?
Have these individuals through their suffering
So what do I miss here? So this one, if you calculate this one, you be getting 980 by omega.
Screen is frozen.
Okay, we are not able to complete your request at this time because of one of your colleague have a problem of the internet, sir, its connection. So I can't, Can you hear me, class? Hello.
Yes, doctor.
Yes, doctor.
Can doctor, but cannot see.
Sorry.
Please.
Your skin is frozen.
The screen froze for 1 to 2 minutes already.
Okay, can you please, what's up? What happened to you now? You don't have a screen.
We cannot see what you write.
Your screen is freeze, doctor.
We cannot see your calculation, doctor.
Professor, the screen stopped sharing.
What do you have now on your screen?
There is no
Okay,
screen.
doctor.
Hold on a bit. It's not in your screen, isn't it? So let me share here something. I'm going to share something here. The connection is interrupted, yeah? Hold on a bit, yeah, class. I'm working. No idea why I cannot share here. Means this one is no. Okay, hold on a bit. This one is one. Check here. So you have. I lost. 1 minute, yeah. I think something wrong with this. Can you hear me? Can you hear my voice, class?
Yes, doctor.
Yes, doctor.
Doctor.
I can hear clearly.
I can't share anything here. Okay, never mind. I'm going to end the meeting. Can you join me back after a couple of seconds? Let's see, 20 seconds. Or work on short things here.
Okay, doctor.
Yeah.
Okay, doctor.
Okay.
Can doctor.
Okay.
Yes, doctor.
I have to end my end the meeting for all. Then come back. Yeah.